By definition, isotopes are atoms of the same element having the same atomic number but different mass number. Let's look into this example. Let's say we have chlorine here, then we have this. This is 1735, 1737. So chlorine exists in two isotopic forms having the same atomic number but different mass number. Like we have here on the board, the atomic number here is 17. For this isotope is also 17. Here we have the mass number to be 35, and here we have the mass number to be 37. Another example is that of hydrogen. Hydrogen exists in three isotopic forms. We have this to be the protium. We have this to be the deuterium or the heavy hydrogen. And we have this here to be the protium. So as we have here, they all have the same atomic number but different mass number. So these are just two examples of isotopes. Then we need to know what we call isotopy, because there is a difference between isotopes and isotopy. Isotopy is a phenomenon whereby atoms of the same element have the same atomic number but different mass number. Isotopes are atoms of the same element having the same atomic number but different mass number. But isotopy is the phenomenon, is the occurrence whereby we have two or more atoms having the same atomic number but different mass number. Then take note of this, that isotopes of an element, they have the same chemical properties but different physical properties. Isotopes of an element, they have the same chemical properties but different physical properties. What do I mean by that? Or what makes it to be so? Why do they have different physical properties? This is due to the difference in the number of neutrons. Like we have here for chlorine. Here is 17, here is 35, here is 17, here is 37. And by now we know how to calculate neutrons. So in order for us to calculate neutrons, it is mass number minus the atomic number. So getting the number of neutrons here, 35 minus 17, it is 18. And here 37 minus 17, this will give us 20. So that shows that they have different number of neutrons. This is the reason why isotope of an element, they have different physical properties. And here the number of neutrons is 0. 1 minus 1, that is 0. 2 minus 1, that is 1. 3 minus 1, that is 2. So they have different number of neutrons. The next thing is, how do we calculate the relative atomic mass of an isotope? How do we calculate the relative atomic mass of an isotope? There are two ways by which you can calculate the relative atomic mass of an isotope. Number one, it is by using the percentage abundance. And then number two, by using the ratio abundance. So I will be giving us the formula that we are going to be using in calculating the relative atomic mass. RAM, which is the relative atomic mass, this equals to M1 alpha 1 plus M2 alpha 2. What does each of these variables represent? M1 represents the mass number of isotope 1, that is that of the first isotope, and M2 represents the mass number of isotope 2. What of alpha 1? Alpha 1 represents the geonormal abundance. Some will just simply call it abundance, which we said it could be in percentage or ratio. So this is the abundance of isotope 1, and then alpha 2 represents the abundance of isotope 2. So please, you need to know what each of these variables represents. M1 mass number of isotope 1, M2 mass number of isotope 2, alpha 1 the abundance or geonormal abundance of isotope 1, and then alpha 2 represents the abundance of isotope 2. So let's look into some examples involving percentage abundance and ratio abundance. Number 1 here says calculate the relative atomic mass of chlorine. If it occurs in two isotopic forms, we have that of 35 and that of 37, with abundances of 75% and 25% respectively. So do not interchange. This has its abundance to be 75% and yet has its abundance to be 25%. Please, like I said, do not interchange. The word says respectively. So don't go ahead changing this to be 75 and then making this one to be 25. No. And you have to note that the sum of the abundance will give us 100%. So let's look into the question. So let's make this to be isotope 1 and then here to be isotope 2. From the formula we said RAM equals to M1 alpha 1 plus M2 alpha 2. What is M1? Which is the mass number of isotope 1. This is isotope 1 and this is the mass number. Please do not use 17. This 17 here represents the atomic number, but we are using the mass number, and that is 35 multiplied by what is the abundance? It is 75%, and that will give us 75 over 100, 75%, plus M2N, that is 37. The mass number of isotope 2, 37, multiplied by what will be the abundance? It is 25%. We have 25 over 100. So this will give us 35 multiplied by 75 divided by 100. This will give us 0.75. And what do we have here? 37 multiplied by this divided by 100. That will give us 0.25. So let's punch our calculator. 35 multiplied by 0.75. This will give us 26.25. 26.25. And for this 37 multiplied by 0.25, this will give us 9.25. So if we add these two values together, we are going to have 35.5. So that means the relative atomic mass of this isotope is said to be 35.5. So what we've done now is to calculate the relative atomic mass of an isotope involving percentage abundance. So the next one is going to involve that of the ratio. All right. So the second question here says the two isotopes of an element, we have Y to be 20, 10, and Y here to be 22, 10, exist naturally in the ratio 3:1 respectively. Do not interchange. This has its ratio to be 3 and then it is 1. The question says, what is the relative atomic mass of Y? So using the same formula, RAM equals to M1 alpha 1 plus M2 alpha 2. What is the mass number of the first isotope here? That is 20. So this is 20 now multiplied by the abundance given to us in the ratio. It is said to be 3 plus the mass number of isotope 2. It is 22. We have 22 multiplied by the abundance given to us in ratio. It is 1. So next thing, 20 multiplied by 3 will give us 60. Then 22 multiplied by 1 gives us 22. So if we add these two together, we are going to have 82. But we are not done. Whenever you have the abundance given to you in ratio, what you have to do is sum up the two ratio. In this case, we have 3, then we have 1. So 3 plus 1, that is 4. So anything we have here, you are going to get it divided by the sum of the ratio. Let's say we've gotten 90, and the ratio given to us was 1:5. Sum up the ratio, which is 1 plus 5, that will give us 6. So 90 divided by 6 will be your answer. So in this case, 82 that we've gotten here divided by the sum of the ratio, which is 4. 82 divided by 4, this should give us 20.5. 20.5. So this is how we calculate the relative atomic mass of an isotope involving percentage abundance as well as that of the ratio. If you've really enjoyed this class, please do well to like, share, and if you haven't subscribed, please subscribe. Thank you.